Let us see the history of Java, components of Java, and installation steps of JDK and example, that is how to execute Java program. Here is the concept map. After this, students should know what is Java Development Kit and Java Virtual Machine. Following are the learning objectives. Learn the history of Java, understand the Java components, understand the JDK tools, and installation steps of JDK. So let us start with history of Java. Java is general purpose object oriented programming language. It was developed by James Gosling, Patrick Norton, Chris Warr, Ed Frank, and Mike Sheridan at Sun Microsystems. It was originally called Oak but was renamed Java in 1994. It was designed for development of software for consumer electronic devices like television, cable set-top boxes, and other electronic machines. Java acronym for names of team members. J stands for James Gosling, A stands for Arthur, V stands for Van Off, and A stands for Andy Bacholism. In the next slide, we will see the Java components. So there are three components of Java: bytecode, Java Development Kit, and Java Virtual Machine. In this slide, we will understand the concept of bytecode. Java bytecode is the instruction set for Java Virtual Machine. The intermediate form of Java program is known as bytecode. So now we will see this concept through example. So this is our source code. I have written this source code in Notepad. Student can write or type this source code in any editor like Notepad or Notepad++. This source code is compiled by Java compiler. When we write a program in Java, the compiler compiles that source code and bytecode is generated. Now, the file which contains this code has .class extension. So this is the file which is having .class extension. This bytecode is platform independent, means it is not machine specific. So Java compiler not only compiles the program but also generates the bytecode for the program. So here we can say that the bytecode makes Java platform independent and secure language. Students need to understand here, when we save our program, you have to give .java extension and bytecode having .class extension. So this is all about bytecode. Second component is Java Development Kit, that is JDK. The Java Development Kit comes with collection of tools that are used for developing and running Java programs. So there are 7 tools. First, Java compiler. It is used to compile Java program. It translates Java source code to bytecode. Second, Java interpreter, and used to run an applet and application program by reading and interpreting bytecode files. Third, applet viewer. It enables to run Java applet. Fourth, Java H. It generates C header files and source files that are needed to implement native methods. Fifth, Java disassembler. It is used to convert bytecode files into a program description. Sixth one is Java debugger. It is used to find errors in programs. And seventh one is Java doc. It is used to create HTML format documentation from Java source code files. Third component is Java Virtual Machine. It is a specification that provides a runtime environment in which Java bytecode can be executed. JVMs are available for many hardware and software platforms. JVM performs following operations: load code, verifies code, execute code, and provides a runtime environment. So here is how JVM works. First, Java code is compiled into bytecode. This bytecode gets interpreted on different machines. So, Java Virtual Machine is responsible for allocating memory space. So this is all about Java Virtual Machine. Now let us see how to install JDK to run our Java programs. First, download JDK. You can download Java 8 from Oracle's Java official website. Student can download any version of JDK. Here is the link is provided to download Java 8. The next step, click on the version you want to download, which is 64-bit version. Go ahead, accept the license agreement and download the file. To start the installation process, run the install by double-clicking it. You will see the installation wizard. Click on Next button. Next step, in this screen, you can change the certain installation default. I accept this as it is. You can change the installation directory if you want by clicking on Change button. Click Next to continue. You will see the installation begins. You will be asked to specify the default installation folder for JRE. I accept the default and click Next button. After this installation will continue, wait for some time for the installation process to complete. Once the installation completes, you will see the installation complete message as Java SE Development Kit 8 Update 241 successfully installed. Click on Close to complete the installation. Here, Java is successfully installed. Now to see exactly Java is installed successfully or not, open your command prompt. Follow these instructions. My JDK is available in program files. So I have typed change directory, that is CD program files. After that Java, after that JDK and bin folder. Here user need to type javac space -help. After clicking on enter, user will get the complete information about Java compiler. This way, I can say that in my machine, JDK is installed successfully. Now, how to execute the program? Let us open editor. I have opened Notepad and I have typed one program to display simple Java program. Save this file in bin folder only. So my class name is AAA. You have to save your file with the class name only. So this is my source file. So extension of this source file should be Java. Save. Now open command prompt. Or directly you can open from C drive. So your JDK is program files, Java, JDK and bin. In this way also you can open your bin folder. Now here using javac, that is Java compiler, you can compile the program. So your file name is aaa.java. So my file is converted into bytecode. To see the effect of this bytecode, you go to this file explorer. Here you can see the two types of files. One is class file, it is generated right now, and one we have created already, that is Java file. Now go to the command prompt to see the output. So you have to type Java instruction followed by name of the file. Here no need to give the extension. Click enter. So in this way you can execute your Java program. So we will take quick review of today's session. First, the intermediate form of Java program is known as. The answer is bytecode. Second question, the file which contains bytecode has extension. So answer is class. And third question for you, give the real-time applications of Java. So answer is web applications, antivirus, smart card and Git. Is provided by Java. So let us see why Java is so popular. So basically it is compiled and interpreted language. Second, platform independent and portable. Third, object oriented programming language. Robust and secure. It is distributed language. Familiar, simple and small. It supports multi-threaded concept and it is interactive. High performance, dynamic, architecture neutral and it is popular for internet. So this is the concept map which shows the features of Java. So let us see the features one by one. First is Java is compiled and interpreted language. Usually a computer language, for example C or C++, can be either compiled or interpreted. Java integrates the power of compiled language with the flexibility of interpreted language. So Java is two-stage system. In the first stage, Java compiler translates source code into bytecode instructions. Bytecode are not machine instructions. So in a second stage, Java interpreter generates machine code that can be directly executed by Java virtual machine. So the two steps of compilation and interpretation allow for extensive code checking and hence improve the security. So this is the concept which shows Java is compiled as well as interpreted language. Second feature is Java is platform independent and portable language. Now what do you mean by platform independent? So the meaning of platform independent is that the Java compiled code, that is bytecode, can run all operating systems. So being a platform independent means a program compiled on one machine can be executed on any other platform. This concept is known as write once, run anywhere. So what happened in the case of C++? The compiler generates an .exe file which is not operating system dependent. When we try to run this .exe file on another operating system, it does not run since it is not operating system dependent and hence it is not compatible with any other operating system or you can say platform. So whenever a program is written in Java, Java compiler compiles it first. The result of the Java compiler is the .class file or you can say bytecode. The bytecode generated is a non-executable code and needs an interpreter to execute on a machine. This interpreter is Java virtual machine and thus the bytecode is executed by the Java virtual machine. And finally program runs to give the desired output. So this bytecode is platform independent and can be run on any machine plus bytecode format also provides the security. So one more important feature is portability. Every system has its own Java virtual machine which gets installed automatically when we install JDK. For every operating system, separate JVM is available which is capable to read .class file or bytecode. So here compiler compiles Java code, convert it into bytecode and Java virtual machine can interpret this bytecode for any platform. Our third feature is Java is an object-oriented language. So everything in Java is an object. All program code and data reside within objects and classes. Java comes with an extensive set of classes arranged in packages that can use in our program by using the concept of inheritance. So everything in Java is object, even the primitive data types can also be converted into object by using the concept of wrapper classes. So following are the basic concepts of OOP: object, class, inheritance, a polymorphism, abstraction, and encapsulation. So our next feature is Java is robust and secure language. Robust means strong. So Java is robust because it uses strong memory management. There is a lack of pointers that avoid security problems. There is automatic garbage collection in Java which runs on the Java virtual machine to get rid of objects which are not being used by a Java application anymore. There are exception handling and the type checking mechanism in Java. All these points make Java robust. When it comes to security, Java is always the first choice because of its bytecode. Java program always runs in Java runtime environment with almost null interaction with operating system, hence it is more secure. So using bytecode concept, we can say that Java is secure language. Our next feature is Java is distributed language. Java comes with the extensive library of classes for interacting using TCP/IP protocols such as HTTP and FTP, which makes creating network connections much easier than in C or C++. Next feature is simple, familiar, and small language. The Java is designed to easy to learn. If you understand the basic concept of object-oriented programming language, Java will be easy to master. There are various features that makes the Java is a simple language. Programs are easy to write and debug because Java codes does not use the pointers. It is much harder to write the Java program that can crash the system, but we cannot say about the other programming language. Java provides the bug-free system due to the strong memory management. It also has the automatic memory allocation and deallocation system. It also eliminates operator overloading and multiple inheritance. Java uses many constructs of C and C++, and therefore Java code looks like a C++ code. Thus, Java is simplified version of C++. Our next feature is multi-threaded and interactive language. Multi-threading means a single program having different threads executing independently at the same time. Java supports multi-threaded programs. Multiple threads execute instructions according to the program code in a process or in a program. Multi-threading works a similar way as multiple processes run on one computer. Next feature is dynamic language. By connecting to the internet, a user immediately has access to thousands of programs and other computers. During the execution of a program, Java can dynamically load classes that it requires either from the local hard drive or from another computer on the local area network or from a computer somewhere on the internet. Next feature is architecture neutral. Means compiler generates bytecodes which have nothing to do with a particular computer architecture. So hence, Java program is easy to interpret on any machine. So here, as we have seen earlier, Java compiler compiles Java code, converts into bytecode, that is .class file, and every operating system has its own Java virtual machine. So we can say Java is architecture neutral. And the last one is Java is popular for internet. The main reason why Java is popular on the internet is that Java offers applet. Applets are small programs which run inside the browser. Before the introduction of applets, the web pages were mostly static. After the use of this application, they have become dynamic, making browser richer. Applets are very safe. They cannot write the local hard disk. Hence, there is no threat of viruses while surfing the internet. This is made applets highly popular on the internet. They also supports graphical user interface. So, we have seen all the features provided by Java. We take quick review based on today's session. A first question for you. Everything in Java is an. The answer is object. Second question for you. Write once, run anywhere means platform independent. Third question. In a first stage, Java compiler translates dash into bytecode instructions. So answer is source code. Learning outcome for today's module is students should understand the concept of classes and objects. So we will learn today how to define a class, how to create a class and object, and how to access the class members. So here is a concept map of today's session. Here rectangle is nothing but name of the class, length and width nothing but variables of class rectangle, and get area is the method of class rectangle. So today we'll start with how to create an object and class. So first we will see how to define a class. So as we know, in Java everything is object and classes. That is why we can say that Java is object-oriented programming language. So class is nothing but user-defined data type. Once a new data type is defined using a class, it can be used to create object of that type. Everything in Java is associated with classes and objects along with its attribute and methods. For example, in real life, a car is an object and the methods of that car is nothing but you can say drive, brake, and attributes is like weight, color of that car. So class is a template or blueprint for an object, and object is an instance of a class. Classes create objects and object use methods to communicate between them. So how to create a class? So let us see the syntax of this class declaration. We can declare a class by using class keyword followed by name of the class. In the square brackets, I have mentioned extends keyword. That extends keyword is useful when we create the inheritance. In the curly bracket, we can declare methods and variables. So this is the simple example based on this syntax. So here I have created a class rectangle by using class keyword. And length and width I have declared the variables of rectangle class type, and get data is the method of class rectangle. Now what do you mean by object? It is a basic unit of object oriented programming and represents the real life entities. So it consists of the following elements: state, it is represented by attributes of an object; behavior, it is represented by methods of an object; and identity, it gives a unique name to an object. For example, identity, name of the dog; state and attributes, age, breed, color; and behavior, sleep, bark, eat. Now in the next slide we will see how to create an object. So there are 3 steps to create an object. First step, how to declare an object. When an object of a class is created, the class is said to be instantiated. Means we have created the object. Declaring a variable to hold an object is just like declaring a variable to hold a value of primitive type. Declaration does not create new object. It's simply variable that can refer to an object. For example, rectangle rect1. So here rect1 is the object of rectangle class. So here we have declared rect1 object of rectangle class. Next step is instantiating an object. So creating an object is also known as instantiating an object. Objects in Java are created by using new keyword or new operator. The new operator creates an object of the specified class and returns a reference to that object. For example, rectangle rect1 is equal to new rectangle. So assign the object reference to the variable. The variable rect1 is now an object of the rectangle class. Our third step is initializing an object. So classes provide constructor methods to initialize a new object of that type. A class may provide multiple constructors to perform different kind of initialization on new object. For example, rectangle rect1 is equal to new rectangle in bracket 10, 20 means I have declared or I have passed this 10 and 20 as length and width of that rectangle rect1. Now how to access the class members? So we can access the class members by using dot operators. So here class members is nothing but whatever we have declared the variables, methods. Those concept is known as class members, and those class members we can access by using dot operators. So here is the syntax. Suppose you want to access the object, so you can write object name dot variable name is equal to value. Suppose you want to access the method, so you have to write object name dot method name along with the parameter list if you have. Let us see this concept with the help of example. So here rect1 is the name of the object. Length and width are the variables. So I have accessed these variables by using object name rect1 dot length is equal to 10. So using dot operator here I am accessing the variables. In the next r1 dot get data. So here I am accessing the method of r1 object. So let us see this concept with the help of example. So in this example, I have created two classes. One is rectangle. Into that, I have declared two variables length and width. And in the next method, get data, I have passed two parameters of integer data type x and y respectively. And in the curly bracket, I have assigned length is equal to x and width is equal to y. In the another method, that is rect area, I have calculated the area of that rectangle by using length into width. In the main class, that is rect area, into that I have created the objects. So here rect1 and rect2 are my objects of rectangle class. Now by using dot operator here I am going to access the variables. So length and width, these are variables, and rect1 is the object of rectangle. In the next rect2 dot get data. So here I have accessed the method by using dot operator. So in this way you can access the class members by using dot operator. So let us execute this concept. So open your notepad and after opening the notepad you need to type the program. So here I have typed same program, I have created two objects over here, rect1 and rect2 of rectangle class. And here I have assigned the values by using dot operator to length and width 15 and 20 respectively. So there are two classes in this program. So your main method in this class, that is area underscore rect. So you need to save this program by using area underscore rect dot java. So here I'll save this program area underscore rect dot java. So my program is saved. Now open your command prompt. So my JDK is in C drive. Yes. So in this way you can open command prompt. So my program name is area underscore rect dot java. So my program is compiled now. Now I want to see the output. So you have to type the name of the file only. Here no need to give extension. So in this way you can execute your program based on classes and object. So let us take the quick review based on today's session. So objects in Java are created using which operator? So answer is new keyword or new operator. The second question is object is an instance of dash dash. So the answer is class. What we will learn today? We will learn token and data types available in Java, dynamic initialization, array and string. So here is the concept map which shows tokens in Java. So here keywords, identifiers, constant, strings, special symbols and operators are the example of tokens. So learning objective is we will learn the Java token. Into that we will see keywords, constant, identifier, string, special symbol and operators. After that we will learn data types, dynamic initialization and array and string. So let us start with Java token. A token is the smallest element of a program that is meaningful to the compiler. So this table gives the complete information about Java token. First one is a keyword. Keyword is nothing but the reserved words. For example, int, break, return, while, etc. Constant is nothing but the expression with a fixed value. They are also known as literals. So in Java, we declare the constant by using final keyword. So here is the example, have final int a is equal to 20. Means value of a, that is 20, is never going to be changed throughout the program. Third one is identifiers. Identifiers are the name of the variables, methods, classes, package and interfaces. So here are some examples, that is hyphen my variable, dollar my variable, etc. String, sequence of characters. The string is the class which is defined by Java. Next one is the special symbol. Symbols other than the alphabets and digit and white spaces. For example, square bracket, parenthesis, curly bracket, etc. And the last one is operator, a symbol that represents a specific mathematical or non-mathematical action. For example, minus sign, plus sign, question mark, etc. So next, what do you mean by keywords? So keyword is nothing but the reserved words. Java keywords cannot be used as identifiers. So Java has a set of keywords that are reserved words that cannot be used as variables, methods, classes or any other identifiers. So here in this table I have mentioned some examples. Those are Java keywords. Point to remember here: true, false and null are not keywords. but they are literals and reserved words that cannot be used as identifiers. Next, we will see constant and literals. Constants and literals is an identifier whose value is fixed and does not change during the execution of the program. So there are five types of constant: integer, boolean, floating point, string, and character. So in this table gives the complete information about literals. So from this boolean you have either true or false value. Next slide we will see the data types. Data types specify the different sizes and values that can be stored in the variable. So we have the classification of data types in Java. We have two categories, primitive and non-primitive. Primitive again categorized into numeric and non-numeric. Numeric is categorized into integer and floating point. Non-numeric data types are categorized into characters and boolean. Next category, that is non-primitive. Non-primitive data types are categorized into class, array, interface, object, and string. So this is all about the classification of data types available in Java. The next table gives the complete information about default value and default size for primitive data type. So first is the boolean. We have default value either false or true, and the default size is 1 bit. Next one is the character. Default value is 0 and default size is 2 byte. Next is the byte primitive data type. For this, default value is 0 and default size is 1 byte. For short data type, the default value is 0 and default size is 2 byte. For integer, default value is 0, default size is 4 byte. For long, default value is 0L and default size is 8 byte. This L means the value is associated with long data type. Next one is the float. The default value is 0.0f and the default size is 4 byte. When we declare the value with 0.0f, this f indicates means the value is belong to float primitive data type. The last one is double. Default value is 0.0d and the default size is 8 byte. The D indicates the value is belong to double data type. So this is all about the data types. Next, what do you mean by variables? A variable is a container which holds the value while the Java program is executed. A variable is assigned with a data type. For example, int a is equal to 20. So variable is name of memory location. So there are some rules for naming variable. Rule number 1, variable names may be any length but must start with letter, either in small case or uppercase, dollar sign or an underscore. Second rule is variable can never use special characters like plus, minus, asterisk symbols. Third, space is not allowed in variable names. Fourth, variable name may consist of numbers, characters, dollar sign and underscore sign, but variable cannot start with number. So always remember, when we declare the variable cannot start with number. Reserved words cannot used as variable name. And the last one, variable name must be unique in its scope. So how to declare the variable and how to initialize the value to the variable. So here is the variable declaration and initialization. So in this example, int is the data type and age is the name of the variable, followed by semicolon. And this variable initialization means Here I have assigned the value 20 to age variable. So simply you have to write age is equal to 20. So this example is nothing but what? Int variable declaration and initialization. So in the next diagram you can see variable declaration and initialization in one line. So int age is equal to 20. So here int is nothing but the data type, age is nothing but the variable name and equal to sign 20. So here you can declare the variable and initialize the value in one line. So this is the way how to declare the variable and how to initialize the values to those variables. Next one is scope of variables, or you can say types of variables. Now what do you mean by scope? Scope of variable is the part of program where the variable is accessible. So there are three scopes: local, instance and class. A variable that is declared inside the method is known as local variable. A variable that is declared inside the class but outside the method is known as instance variable, and the variable that is declared as a static is known as static or class variable. So this complete information about scope of variables we will see in the unit number 2. Next one is dynamic initialization. Initializing a variable at runtime is called as dynamic initialization. Java allows variables to be initialized dynamically using any expression valid at the time the variable is declared. When variable initialized at the time when it is declared, this type of initialization is called as dynamic initialization. So, why dynamic initialization is required? Because it utilizes memory efficiently and it has the flexibility of using different formats of data at runtime considering the situation. So in this example, here you can see double x is equal to 100.0 and double result is equal to math.sqrt of x. So here result is declared dynamically. Means whenever I require the variable I have declared over here. So this is nothing but the dynamic initialization. Next one is array and string. An array is the collection of similar types of data. For example, if we want to store the name of 100 people, then we can create an array of string data type that can store the 100 values. Syntax: data type along with the square brackets and name of the array. So here I have mentioned one example: double as a data type along with the square bracket and name of the array is %. So in Java we can initialize array during the declaration. For example, int square bracket age is equal to curly bracket whatever the values we want to assign to age array. String. String is basically an object that represents the sequence of character values. An array of character works same as Java string. So here is a simple example which shows the string object. So here S is the object of string is equal to new string ch. Ch contains the characters M, S, B, T, E. So here we will take the quick revision of today's session. First question for you: what are the categories of data types? Answer is primitive and non-primitive. Next question for you: dash are expressions with a fixed value. Answer is constant. Constants are the expression with a fixed value. We declare the constant by using final keyword. And the third question is identify the identifiers from following example. So here is the program. From this program you have to identify it. Means What are the keywords available in this program? Identifiers, tokens, symbols, like that. So here is the answer. Main, you can say this is the identifier. Then these brackets are symbols. Int is keyword. X, Y sum, these are the identifiers. And these are the tokens. First one is arithmetic. Next, increment and decrement. Next, comparison or relational. Fourth one is assignment. Fifth one is bitwise. Sixth one is shift. Seventh one is logical. Eighth one is conditional. And last one is special operator. So, in this concept map, which shows operators available in Java. So, today what we will learn? We will learn all the operators along with the examples. So, let us start with arithmetic operator. Arithmetic operators are used in mathematical expression in the same way that they are used in algebra. So, addition, subtraction, multiplication, division and modulo. These operators belong to arithmetic operator. So, addition, x is equal to y plus z. Add the value of y and z and store the result in x. Next one is subtraction. X is equal to y minus z. Subtracts z from y and store the result in x. Multiplication, x is equal to y multiplied by z, multiplies the values y and z and store your result in variable x. Division, x is equal to y divided by z. Divides y by z and store the result in x. A modulo, x is equal to y modulo z, that is divides y by z and whatever the remainder is coming, which is stored into variable x. So this is a simple example based on arithmetic operators. I have performed all the arithmetic operations on A and B, and here is the result. Our next operator, increment and decrement. So plus indicates increase the value of the operand by 1. For example, x plus plus equivalent to x is equal to x plus 1. Next one is minus means decreases the value of the operand by 1. For example, x minus minus equivalent to x is equal to x minus 1. For example, initially the value of number is equal to 50. After performing number plus plus, it becomes 51. And after performing decrement operation on number, it becomes 50 again. Our next operator is pre-increment, post-increment, pre-decrement and post-decrement operator. So initially value of x is 3. Now expression is y is equal to x plus plus. So final value of x is 3 and final value of x is 4. Next, y is equal to plus x. So final value of y is 4 and final value of x is also 4. The next expression, y is equal to x minus minus. So final value of y is 3 and final value of x becomes 2. y equal to minus x. That means final value of y is 2 and final value of x is also 2. So this is how pre-increment and post-increment operators are evaluated. So here I have declared 5 variables a, b, c, d, e and I have assigned 5 value to variable a. I have performed b is equal to plus a. After executing this, the value of b becomes 6 and a also becomes 6. Now after that I have performed c is equal to a plus plus. So after result of this pre-increment, your a is 7 and c is 6. So in this way, you can perform pre-increment and post-increment operators. Next, comparison or logical operator. So there are 6 comparison operators. First one is equal to. Evaluate whether the operands are equal. For example, s is equal to y. Returns true if the values are equal, otherwise false. Next one is not equal to. Evaluate whether the operands are not equal to. Next one is greater than. Evaluate whether the left operand is greater than the right operand. Next, less than. Evaluate whether the left operand is less than the right operand. Next one, greater than or equal to. Evaluate whether the left operand is greater than or equal to the right operand. And the last one is less than or equal to. Evaluates whether the left operand is less than or equal to the right operand. Our next, that is, explains the concept of comparison operator with the help of example. So here I have declared two variables a and b, that is 10 and 20. If in this I have mentioned a is equal to b, that means the value result is false because a and b, the value are not same. In the next, a is not equal to b. In that case, your result is true. So likewise, you can perform comparison operators in Java. Our next operator is assignment operators. So assignment operators are used to assign the value of an expression to a variable. So there are 6 assignment operators. First one is equal sign. Assign the value of the right operand to the left. For example, x is equal to y. That means assigns the value of y to variable x. Next one is plus equal to. Adds the operand and assign the result to the left operand. For example, x plus equal to y, which is equivalent to x is equal to x plus y. The next, minus equal to. Subtracts the right operand from the left operand and store the result in the left operand. For example, x subtraction equal to y. It is equivalent to x is equal to x minus y. That means subtract the value of y to x and your result is stored in variable x. Next one is multiply by and equal to. Multiply the left operand by the right operand and store the result in the left operand. For example, x multiply by equal to y, which is equivalent to x is equal to x multiply by y. Next operator is divide by equal to. Means divide the left operand by the right operand and store your result in left operand. For example, x divided by equal to y. That means divide the value of y to x and save your result in variable x, which is equivalent to x is equal to x divided by y. Our next is division, that is modulo equal to. Divides the left operand by the right operand and stores the remainder in the left operand. So, for example, x modulo equal to y, which is equivalent to x is equal to x modulo y, which saves your result in variable x. So, while performing the assignment operators, you have to always remember whatever the operations performed, your result is stored in the left operand. Let us take the example. So here I have created one variable, that is x is equal to 5, and I have performed modulo equal to operation on x. So after executing this program, when you perform modulo equal to, your result is 2, which is returns the remainder of this operation. So in this way you can perform the assignment operators. The next operator is bitwise operators. So these bitwise operators are used for testing the bits, or you can say shifting the bits right or left. And these operators may not be applied to float or double data type. So there are 4 bitwise operators: AND, OR, XOR and inversion. Let us start with AND operator. AND results in 1 if both the bits are 1. Any other combinations result in 0. Next, OR results in a 0 when both the bits are 0. Any other combination result is 1. XOR results in 0 if both the bits are the same value and 1 if the bits have different values. Inversion, that means convert all 1 bits to 0 and vice versa. So let us take the example which explains the concept of bitwise operator. So here I have declared two variables, a is equal to 60 and b is equal to 13, and I have declared another one, that is c, to store the result. So 60 is a decimal. We have to convert this 60 into binary. So binary value of 60 is 00111100 and 13 00001101. So I'll explain a and b. So here you can see in this diagram, a is equal to 60 and b is equal to 13. So 16 is a decimal number. The binary of this 00111100 and 13 binary is 00001101, and I have performed AND operation on a and b. So a and b AND operation nothing but, if your input of both the values is 1, then only your output is 1. So in this case, here you can see, if the value of a and b as input are 1, your result is 1. Other any combinations, results are 0. And this 00001100, this binary is equivalent to 12 decimal. So after performing a and b, your result is 12. So likewise you can perform bitwise operators. Our next operators is shift operator. So first one is right shift operator, next one is left shift, and third one is unsigned right shift. So this right shift means shifts bit to the right, filling signed bits at the left, and it is also called as signed right shift operator. Now next, shift bit to the left, filling 0 at the right. So let us explain this example through the figure. So this example elaborates the left shift operator, which is shifted by 1 bit to your left side. So your initial value of this 0010, and you have to shift a bit to your left side, and after shifting this, your replacement bit should be 0. So in this way you can perform the shift operators on binary numbers. For example, here we have declared x variable and I have assigned the 7 to x, and I have performed all the shift operators on this x variable only. So let us start with the explanation of this code. So initially your value becomes 7. So 7 binary equivalent is 0111, and I have used the right shift. Right shift towards by 2 bits, and I have shifted this right shift 2 bits towards your left side. So this 1 1 I have shifted by 2 bits to your right side. So your result is 0 1, and remaining 2 bits are filled with 0 bit. So your result is 0001. So after performing x right shift operator 2, your result is 1. So in this way you can perform shift operators. The next operator is logical operator. Logical operators are used when multiple conditions are going to be performed. And, or. So and operator evaluates to true if both the conditions evaluate to true, otherwise false. For example, x greater than 5 and y is less than 10. So in this case, the result is true if both the conditions are true, otherwise false. Now next one is or evaluates to true if at least one of the conditions should be true, otherwise false. So let us take the example based on these logical operators. So here you can see, here 5 is greater than 3 and 8 is also greater than 5. Means in this statement, my both the conditions are true, so your result is true. But in the next, 5 is greater than 3, yes, true, but 8 is less than 5, no, it is false. So your result is false. So in this way, you can perform the logical operators. Next, conditional, or you can say ternary operator. The goal of the operator is to decide which value should be assigned to the variable. Ternary operator represents question mark and colon. Basically, it is used for if then else as a shorthand. Here is the syntax. Boolean expression means true or false. Question mark operand 1 colon operand 2. This is the graphical representation of your syntax. Now we will see the example based on this ternary operator. So this program evaluates even or odd number. So I have explained this through ternary operator and I have given equivalent to if else. So your number is 13. If number modulo 2 is equal to 0, it will print even number if the condition is true. Otherwise, it will return false. So in this case, your number is 13, which is not equal to 0. Means it will return odd number. So here is the output of ternary operator. So if you want to perform even or odd number, you can perform this task by using ternary operator or if else. Our next operators are special operator. First one is new operator. New operator when we use to allocate the memory to the object. When you create an instance of a class, you need to allocate the memory for that. When you declare an object, you merely state its data type. For example, pen, black pen. So here pen is nothing but the name of the class and black pen is nothing but the variable. That means I have not assigned the memory to black pen. To assign the memory, we need to use the new keyword. So to allocate the memory, you need to use new keyword or new operator. So you can allocate the memory by using two ways. First, declare the object. After that, you can allocate the memory by using new. So here is the syntax. Class name, object name. In the next line, you need to write object name is equal to new along with the class name. For example, so here pen, black pen is equal to new pen. And the second way, declare the object and at the same time allocate the memory by using new keyword. So here is the syntax, class name, object name is equal to new class name. And here is the example, pen, black pen is equal to new pen. So in this way, you can assign the memory by using new keyword or new operator. Next, dot operator. So dot operator access the instance members of an object or class members of a class. For example, company.salary or you can say company.employee. The next, parenthesis operator. When declaring or calling a method or function, we list the method's arguments between parentheses. We can specify an empty argument list by using opening and closing bracket with nothing between them. Third, square bracket. These square brackets are useful when we declare the arrays. For example, int name square bracket. Next one is type operator. This operator is useful to convert one data type to another. And the next one is instance of. The instance of operator tests whether the first operand is an instance of the second operand. For example, x instance of y. So here x is nothing but the name of the object and y is nothing but name of the class. So this operator is used only for object reference variable. So here is the class. I have declared two classes, class vehicle and class car. Class vehicle is my superclass and class car is my subclass. And I have declared the variable vehicle A is equal to new car and boolean result is equal to A instance of car. So in that case, yes, A A is the name of the object and car is the name of the class. So your result is true in that case because A is the instance of car class. So in this way, we have studied all the operators which is available in Java along with the simple example. Today we will learn operator precedence. What do you mean by precedence order? Associativity, expressions of evaluation, math function and typecasting. So today's key learning points are operator precedence, expression of evaluation, math function, typecasting along with its types, that is winding and narrowing. So let us start with operator precedence and precedence order. So when several operations occurs in an expression, each part is evaluated and resolved in a predetermined order called as operator precedence. Operator precedence determines the order in which the operator is an expression are evaluated. When two operators share an operand, the operator with the higher precedence goes first. For example, int a is equal to 12 minus 4 multiplied by 2. Now, what will be the value of variable a? Will it be inside the brackets 12 minus 4 bracket complete multiply by 2 which is equal to 16, or it will be 12 minus inside the bracket 4 multiplied by 2 which is equal to 4. So here is answer 4 because when two operators share a common operand 4 in this example, the operator with the highest precedence is operated first. So in our example, the precedence of multiplication operator is higher than the subtraction operator. Hence the multiplication is performed before the subtraction and hence the value is 4. So in this way, you can apply the precedence order. So this table lists the precedence operators in Java. Higher it appears in the table, higher its precedence. Now let's see the associativity. When two operators with the same precedence, the expression is evaluated according to its associativity. For example, x is equal to y is equal to z is equal to 7 is treated as x is equal to inside bracket y, inside bracket z is equal to 17 and all brackets are complete, leaving all three variables with the value 17. That means the equal to sign, equal to operator has right to left associativity. Whereas in the another example, we have 70 divided by 2 divided by 3 is treated as 70 divided by 2 first and then divided by 3. Since the division operator has left to right associativity. This table gives the complete idea about precedence and its associativity. So here right now we have seen these multiplicative operators having left to right associativity, whereas ternary operator and assignment operators having right to left associativity. Now we will see expression of evaluation. An expression is a construct which made up of literal variables, methods and operators. Every expression consists of at least one operand and one operator. Operand can be either a literal, variable or method. It is common for an expression to have more than one operator. So here is the example in this code shows the concept of evaluation of expression. So in this way, the Java compiler evaluates our expression and here is the output after performing this code. Now we will start with mathematics function. So these mathematical functions such as sine, cos, square root, minimum, these are used to analyze the real life problems. For example, suppose you want to find out the square root of a number, power of a number. So in that case, these mathematical functions are helpful. Java supports these math functions through math class, which is defined in java.language package. For example, in this case, y is equal to math.sqrt of x. So here, math is nothing but the class, and sqrt of x is nothing but the method provided by math class, and that math class is available in java.language package. So now we will see the functions one by one. So first one is the absolute, which is known as ABS method. It is used to find absolute value. So absolute value means when we suppose give the negative value as an input, your output should be positive. So in this case, in this example, mat.abs minus 2.3. So your output is 2.3. Next one is the minimum. Minimum method is used to find the minimum value between variable 1 and variable 2. So here in this example, I have provided 2, 8, and this minimum function find out the minimum value, which is 2. Next one is the maximum. So maximum method is used to find maximum value between the variable 1 and variable 2. So in this case, the output is 8 because out of 2 and 8, 8 is the maximum. Next one is the SQRT, that is square root. So this method is used for finding square root of a given number. So here SQRT of 9, it will return 3 as an output. Next one is the EXP, that is Euler's number e raised to the power of a variable. So here EXP of 2 is 7.389. Next method is sign, to calculate the sign of a value. So here in the example, sine of 82.55 is 0.94. Next method is cos, to calculate the cosine of an angle. So here I have used cos of 82. So your answer is 0.94. And later on I have used tan method. It is used to calculate the tangent of a number. So here in the example, tan of 80 is 9.0036. Next, cell method. In arithmetic, the ceiling of a number is the closest integer that is greater or higher than the number considered. Cell method is used to round up the variable. So here in this example you can see mat.cell I have used 12.15. So 12.15 is near to integer, that is equivalent to 13. And here minus 12, 24.06, it near to 24, so that is the answer is minus 24. Now next one is the floor. This is the floor function which returns you the largest value but less than the argument. Floor method is used round down the variable. For example, math.floor 8.4, which is equivalent to 8, and math.floor inside the bracket minus 24.06, which is equivalent to minus 25. Now copy sign. This method is used to copy the sign of variable 2 and assign that sign to variable 1. For example, copy sign 2 minus 8.3. So your output is minus 2. So the sign of this second parameter, that is variable 2, is copied to variable 1, that is 2. So your output is minus 2. Now rounds the nearest integer. So here round 1.02, it will give the value 1, and round minus 2.1, it will give the output minus 2. Random, this is the random function which returns you the random number. It is absolutely system generated. This method can be used to produce a random number between 0 and 100. So it can give any number between 0 and 100. Now log returns the natural logarithm of the argument. So log of 2 is 0.69. Here is the simple example which demonstrates the use of math functions. So in this example I have used max method, sqrt method, power method, log method, exp method. So and after utilizing these methods, here is the output of this source code. So next slide we will see what do you mean by typecasting. So typecasting means converting one primitive data type into another is known as type conversion or typecasting in Java. You can cast, you can convert the primitive data types in two ways, either by widening and by using narrowing. So widening is nothing but converting a lower data type to a higher data type. In this case, the casting or conversion is done automatically. Therefore, it is known as implicit type of casting. In this case, both data types should be compatible with each other. So, in this diagram you can see byte code can convert into short, int, long, float or double. Short data type can be converted into int, long, float, double and so on. So, in this code, int a is equal to 9. Now, we have assigned this integer a's value to double b variable. So, here integer gets converted into double data type. In this way, Java supports automatic casting. So, here is the output of this source code. So, here initially a is equal to 9, which is integer, and I have converted this a's value into double, that is 9.0. So, this concept is known as winding typecasting. It is also known as implicit typecasting. Another one is narrowing. So, converting a higher data type to a lower data type is known as narrowing. In this case, the casting or conversion is not done automatically. You need to convert explicitly by using cast operator explicitly. Therefore, it is known as explicit typecasting. So, in this figure, double data type can get converted into float, long, int, short or byte. Float data type can get converted into long, int, short, byte and so on. So in this example, I have mentioned double a is equal to 9.78. Now this double you can convert into integer. So how it convert? Int b is equal to int of a. So here we need to specify the type of data type. So this is known as explicit casting. So here I am going to convert this double into int. And after executing this, your output is this. So in this way, you can perform the conversion from one data type to another. So today we will learn all the decision making statements. If statement, if else if, nested if and switch case. So here is the concept map which shows if else and switch case statement. So today's learning objectives are if else if, nested and switch along with the example. So let us start with first, that is if statement. If statement tests the condition. It executes if block if condition is true. So here is the syntax. If condition is true, then it executes the block. So here is the simple example which demonstrates the use of if statement. See here I have declared the age variable and I have assigned 20 value to that. And I have checked the condition if age is greater than 18. And inside the curly bracket I have print age is greater than 18. So the output is age is greater than 18 because the mentioned age, that is 20, is greater than 18. So this if statement simply executes the block if condition is true. The next statement is if else. Java if else also tests the condition. It executes the if block if condition is true, otherwise else block is executed. The syntax says like this only. So syntax says it execute the block if the condition is true, otherwise else block is executed. Here is the simple example which shows the number is positive or not positive. So I have declared the variable, that is number, and I have assigned -10 to that variable. And when condition is true, then in that case the number is positive. But in my example, the condition is false because number is not greater than 0. means the number is not positive. Here is the output. Third, if-else if ladder statement. So, if-else if ladder statement execute one condition from multiple statements. Here is the syntax. If condition 1 is true, then the next block will be executed. Else if another condition is true, another block gets executed like that. So here is the example to demonstrate the if-else if ladder. If number is greater than 0, then number is positive. Else if number is less than 0, the number is negative. Else number is 0. So here is the output of this source code. Fourth one is nested if statement. The nested if statement represents the if block within another if block. Here, the inner if block condition executes only when the outer if block condition is true. So here is the simple example to demonstrate the nested if. So here I have declared 3 variables and assigned the values to those 3 variables, and I have declared one more, that is largest. And here I have checked the condition n1 is greater than equal to n2, and inside this I have again checked the condition n1 is greater than is equal to n3. Means this condition should be true and this condition should be true. Then only these blocks gets executed. So here largest number is 4.5 as n1 and n3 are in negative. Last one is the Java switch statement. So Java switch statement executes one statement from multiple conditions. It is like if-else if ladder statement. The switch statement works with byte, short, int, long, enum type, string and some wrapper types like byte, short, int and long. In other words, the switch statement tests the equality of a variable against the multiple values. So here is the syntax. So some points to remember while using the switch case. There can be one or multiple cases for a switch expression. The use of break and default keywords are optional. The case statements can only include the constant or literals. It cannot be an expression or a variable. Unless you put a break after the code of every block, the execution will continuously flow into the next block. It is not necessary that the default case has to be placed at last in a switch block. So here is a simple example which demonstrates the switch statement. So this code gives an output of respective day based on the case. So here my case is 1, 2, 3, 4, 5, 6 and 7, which shows the number of days. So I have executed this code on Saturday. So in this code day is equal to 6 and therefore output is Saturday. So now we will see the use of break keyword. The break statement in Java is used to terminate from the loop immediately. When a break statement is encountered inside a loop, the loop iteration stops there and control returns from the loop immediately to the first statement after the loop. Here is the simple example to demonstrate the use of break keyword. So here as you can see I have used a for loop. In that for loop I have assigned I is equal to 1, I is less than equal to 10 and I plus plus. And inside for loop I have give the condition that is if I is equal to 8. So the output is it will print 1 to 7. So after 8 the iteration the loop will be break. So the output is 1 to 7. Now let's see the use of continue keyword. The continue statement in Java is used to skip the current iteration of a loop. And we can use this continue statement inside for while do while loop. So here is the example to demonstrate the use of continue. So same example, but I have used the continue keyword over here. If I is equal to 5 and curly bracket I have mentioned the continue. That means I is equal to 5. Skip the current iteration and continue the loop. Means in my output, it will display from number 1 to 10, but it skips I is equal to 5. Let's see the output. So here it will print 1 to 10 but not 5. Means that 5 skip the iteration in the continue keyword. So what is the difference between break and continue keyword? So the answer is break terminates the execution of remaining iteration of the loop, whereas continue terminates only the current iteration of a loop. Break stop the continuation of loop, and continue do not stop the continuation of loop, it only stop the current iteration. So break can be used in switch, but continue cannot be used with switch. It will use in while, do while and for loop. So in this way you can use the decision making statement as per the requirement. But in Java, it will provide 4 kinds of looping statements. That is for loop, for each loop, while loop and do while loop. So here is the concept map which shows the types of loops in Java. So today we will start with this while loop, do while loop, for loop and for each loop one by one along with its syntax and example. So let us start with while loop. Java while loop is used to iterate a part of program several times. If the number of iteration is not fixed, it is recommended to use while loop. Means if you don't know the number of iterations, in that case you can use while loop. So here is the syntax and here is the example to show the use of while loop. So the output is simple 1 to 10 print. So here I have initialized I is equal to 1. And using while loop, I have mentioned the condition, that is I is less than equal to 10. In the curly bracket, I have used the executable code. In that executable code, I have used system.out.println and I have used I++. You can write I minus minus also to reverse the numbers from 10 to 1. Next one is do while loop. Java do while loop is used to iterate a part of program several times if the number of iteration is not fixed and you must have to execute the loop at least once. In that case you can use do while loop. Java do while loop is executed at least once because condition is checked after loop body. So the syntax says about this. So here we can mention the condition after your loop body, and this is the example which prints 1 to 10 numbers. But in this case, your condition is evaluated after the block. I mean after your loop body. Next loop is for loop. Java for loop is used to iterate a part of program several times. If the number of iteration is fixed, it is recommended to use for loop. Here is the syntax to demonstrate the for loop. First, you need to initialize, then you have to mention the condition, and later on you can use increment or decrement. In the curly bracket, you need to write the executable code. So here is the example to demonstrate the use of for loop. So this program print 1 to 10 numbers. So in this for loop, I have initialized I is equal to 1, then condition is I is less than equal to 10 and increment means I++. In the curly bracket, it simply prints I's value, that is from number 1 to 10. If you want to print reverse numbers, in that case you have to decrement I minus minus. The next loop is for each. This is the advanced version of your simple for loop. This for each loop is used to traverse an array or collection in Java. It is easier to use than simple for loop because we don't need to increment the value. So here is the syntax and example. So syntax is, in the for loop, you need to mention the data type, then name of the variable, colon, name of the array. So in this example, I have declared an array and initialized the value to that array, that is ARR. And now I want to print that array by using for each. So for, in the bracket, I have write int, that is data type. Then I, that is variable name, colon ARR, that is the name of the value. that is name of the array. So by using this for each, you can print or you can traverse the array or collections. So this is what the expected output. So in this way, you can print the elements of array by using for each without mentioning increment or decrement the value. So in this way, you need to understand whether to use the loops. For example, if your iterations are fixed, in that case, you can use for loop. If your iteration is not fixed, you can use either do while or while. But you need to execute your loop at least once. In that case, you have to use do while. And last, if you want to print collections or array in the Java, in that case, you have to use for each loop. So in this way, based on the requirement, you have to understand where to use looping statements in our programs. Thank you, students.